We will be talking about section 4.3, polynomial functions. What is a polynomial? And we've seen this definition before, and I've tried to make it a little simpler for you. If we just look at each term individually, then we're looking at ax to the n, where n is a non-negative integer. And that is called the degree. And then we have a, the number in front of the x's, and it has to be a real number. And a real number is any number that you can find on the number line. And we call it a coefficient. And then we can put these together and we get this plus this. It could be minus because a could be plus or minus. It's a real number. It could be a positive number. It could be a negative number. Whatever it is, that's what the sign will be. And we just keep going until we get down to the end. And the number a0, if you ask for the constant, a0 is going to be a constant. There's just not many x's next to it. It's just a value. And the leading one is the first one. When we put it in standard form, we always put it in descending order, the exponents in descending order. A0 is the constant coefficient, and a sub n, which is the first one, is the leading coefficient. The power of each term must be an integer greater than or equal to 0. So remember what that means. It can't be a fraction because fractions are not integers, and it can't be a negative number because obviously negative numbers are not greater than or equal to 0. The coefficients are real. So polynomial functions, even though this has a square root of 5, it's still a real number. X to the fourth, 4 is our degree. That's fine. That's an integer. That's an integer. Remember, we said that even this 6 is the same as saying x to the 0 because x to the 0 power is equal to 1, but we have to make sure that x is not equal to 0. That's a polynomial. The next one is a polynomial. Even though it's got a denominator, we could rewrite it as 4 over 17 x to the third minus 2 over 17 x squared plus 5 over 17 x minus 1 over 17. Because each one of those now has a coefficient that's a real number, I can say this is still a polynomial. Even though it's got a denominator, the denominator is a constant. It doesn't change the fact that it's a polynomial. Now we look at non-polynomial functions. This is not a polynomial. Even though the numerator is a polynomial, we cannot have a variable in the denominator. A polynomial over a polynomial, which is what this is called a rational function. This is not a polynomial because I have a variable now in the denominator. Determine which functions are polynomial functions. Let's do that first. Is the first one a polynomial? Well, I have a degree 3, 2, and 0 because there's no x on the last one. So yes, all the coefficients are real. Yes, yes, this is a polynomial. B, is B a polynomial? Well, I have an x in the denominator. Everything up to that point was okay. If I just take out that one term, it's a polynomial. But that term, if you have x to the negative 1, that's the same as 1 over x. The rule is if you have the base to a negative power, it becomes 1 over the base to a positive power. If I wanted to rewrite this, 7 over x is the same as 7 times x to the minus 1 power. Now we can see that the exponent is not greater than or equal to 0, which makes it no, this is not a polynomial. If the function is a polynomial, so now if the function is a polynomial, we don't even have to deal with b. We've already finished b. But now for a, it is a polynomial. We want to identify the degree. The best way to rewrite these is always in descending order of exponents, which this already is. And the degree is always the largest value. That's the degree. That's 3. This is 2. And again, this would be 0. But we want the degree of the entire polynomial is the largest one, which is 3. The leading coefficient is equal to the square root of 3. And the constant coefficient is the last term. There's no x, which makes it constant. If there was an x, then it would make it variable because it can change. So this becomes minus 1/6. Determine which functions are polynomials. Is this a polynomial? Well, yeah, it's a polynomial because I can rewrite this as 7x to the 4th over 9 minus x squared, or minus 1/9 times x squared. I can rewrite this, and then I have plus 3 over 9 times x, which I can simplify this to 1/3 x. That looks like a polynomial to me. I have my coefficients, 7/9 minus 1/9 and plus 1/3. And I have x's all having a positive degree. This degree here would really be the same as to the first power. Yeah, this is a polynomial. I put them in order. The degree is 4. It's the largest exponent. The leading coefficient is 7/9. And the constant coefficient is equal to, we have no constant here, so 0.